So in this video, we're going to use what we've previously discussed in the last video, and we're going to solve some questions related to the topic. So just as a quick refresher, if you have a quadratic equation as ax squared plus bx plus c, then if a is positive, then you have a graph that is concave up. Your turning point is a minimum point. So your graph is concave up, your turning point is a minimum point. If a is negative, it's concave down, and your turning point is a maximum point. Alright, and this is something that we have discussed in the previous video. And whether it's the minimum point or the maximum point, basically your turning point is also known as the vertex, and the equation for your vertex is minus b over 2a. So the coordinates of your vertex is at minus b over 2a, comma, c minus b squared over 4a. So that is the coordinate of your vertex. And we have seen how we have come to this conclusion from the previous video. And in this video, we're also going to look at how you can use another method to get the coordinate of the vertex if you don't want to use the formula directly. But for part A, we're just going to use the formula. So A is 1. 1 is positive, so it's concave up. For part A, for part B, it's same. It's concave up as well. For part C, it's concave up. For D, you have negative 1 as A, right? A is negative 1, so it has to be concave down. All right. So now, let's see. So for part A, so we won't do all the questions. We'll do whatever we can. So 1a is we have x squared minus 6x plus 8. So as we have discussed, it's going to be concave up because the coefficient of x squared is 1, 1 is positive. So it's concave up, right? So the vertex, the equation of the vertex is minus over 2 times 1, right? Minus b over 2a, comma. So minus b is negative 6 over 2 times a is 1, right? So minus b over 2a is this expression. So b is negative 6 divided by 2a is 2 times 1, and we have minus b over 2a, right? So we have this expression here. And the other part is c, which is 8 minus b squared over 4a. So b is negative 6. So negative 6 squared times 4 times 1 is just 4. So the coordinates of the vertex is, this expression just gives us 3. And the second part is 8 minus 36 by 4. 8 minus 9 is negative 1. So your vertex is at this point. And your vertex is also your minimum point, because it's concave up. So you have a minimum point. Your vertex is your minimum point, which is this equation. So minimum point, your because it's concave up, right? So this point is your vertex, which is also your minimum point. So you have a minimum point at 3 comma negative 1. And let's solve for the intercepts. So if I say y is equal to x squared minus 6x plus 8, then your y-intercept, which means you set x is equal to 0. So if x is equal to 0, y is equal to 8, I believe. So this will be 0. The first part will be 0. The second part will be 0. And you just have the third part, right? So you have 0 comma 8. That is 1 point on your graph. And you want to find the intercept. So if you put y is equal to 0, so you solve for the x-intercepts. If you want the y-intercept, you put x is equal to 0. If you want the x-intercepts, you put y is equal to 0. So x squared minus 6x plus 8 is equal to 0. This is something that you can factorize. So you get x minus 4, x minus 2 is equal to 0. Therefore, x is equal to 4 and x is equal to 2. So you have zeros at 4 comma 0 and 2 comma 0. So if x is 4, y is 0, and if x is 2, y is 0. So now you can draw a very rough sketch for the graph. So you plot your 2 points, right? So you point 4 comma 0 and 2 comma 0. So let's say this is 2 comma 0, 2 comma 0, and this is, let's do it in another way, sorry. So let's say this is 2 comma 0, this is 4 comma 0. So 4 comma 0, 2 comma 0 is here. And actually your vertex has to be at the average of your x-intercepts. So the average of 2 and 4, that is 3. So your x-coordinate of your vertex has to be 3, which it is. It's 3 comma negative 1. So your 3 comma negative 1 is somewhere here. So 3 comma negative 1 is somewhere here. So just think that each box here, each line here represents 1 unit. And then you have 0 comma 8. So if x is 0, then 1, 2, 3, 4, 5, 6, 7, 8 is somewhere here. All right, so now that we have this, let's join all our points to draw the curve. So our curve looks something like this. So it's concave up. It has a minimum point at 3 comma negative 1. And it passes through these points, right? So it looks something like this. I know the drawing is a bit improper, but I hope you get the idea. So it is a parabola that's concave up. Its minimum point is at 3 comma negative 1. Its x-intercepts are at 2 comma 0, 4 comma 0, and its y-intercept is at 0 comma 8. So this is how your graph should look like, a bit proper. You can draw it using a proper scale, and it's symmetrical about this line. This is your axis of symmetry. X is equal to 3. All right, so we are done with part A. So we don't really have time to do all of the questions. And again, some of these are not that easy to draw, especially when I don't have the proper graph paper. So you won't do all of them. So let's do part D. And you can use the same method to try for C and B. But part D gives me y is equal to 12 plus x minus x squared, right? So let's do it step by step. Step 1, I want the y-intercept. To get the y-intercept, you put x is equal to 0. And if you put x is equal to 0, you get y is equal to 12. So that is the y-intercept. To get the x-intercepts, you solve the equation y is equal to 0 is equal to 12 plus x minus x squared, right? And let me just multiply by negative x. So I get x squared minus x minus 12. So if you solve this equation, so I just multiplied by negative 1 on both sides. So I multiplied by negative 1 here and negative 1 here, I get this equation. And can I factorize this? Let me think. I believe so. If x minus 4x plus 3, that should give me the solution. So therefore, x is equal to 4, x is equal to negative 3. So my solutions are 4 comma 0, negative 3 comma 0. So those are my x-intercepts, right? All right. This is my y-intercept. Now let's find the equation of the vertex. So the vertex is at minus b over 2a, comma c minus b squared over 4a. That is something that we previously derived, or you can use the average method, right? So you just take the average. So minus b over 2a. So this is our equation. So b is 1. So negative 1 over 2 times negative 1, right? 2 times negative 1. So remember, you want to rearrange this in terms of decreasing power if you're confused. So this is a, so negative 1 is a, b is just positive 1, and c is 12. So negative 1 minus b is positive 1 divided by 2 times a is negative 1, comma. And then c is 12 minus b is 1. So 1 squared is 1 divided by 4 is 4a is just negative 4. All right, so now we can simplify this. This gives us 1 over 2, comma, 12 plus 1 over 4. So 12 plus 1 over 4, I think that is 49 by 4. Or you can just leave it at 12, 1 over 4. But that is your maximum point. Why? Because your coefficient of your x squared term is negative, so it's concave down. And the concave down graph has a maximum point. So you want to draw your graph something like this. So this is your graph. you have intercepts at, let's say this is -3 comma 0, this is 4 comma 0, right? And then your vertex is at 1 half, so half, let's say somewhere over here, half comma 12 1 over 4, half comma 12 1 over 4, somewhere here, half comma 12 1 by 4. That is your maximum point. Your graph is concave down, and your x-intercept is at 0 comma 12. So let's say 0 comma 12 is somewhere here. So this point is 0 comma 12, and then you just want to join your points, right? You reach your maximum point, and again, remember, you want your maximum point to be smooth. So something like this, you need a horizontal tangent here. So I know this is not the best looking graph, but I hope you get the idea. It's very hard to draw on an iPad. So it's going to be a concave downward graph that looks something like this, but it's better if you draw it a bit more properly. All right. So you can feel free to try C and B on your own. I think the numbers are a bit messy on those two questions, but you can just try to give a rough sketch rather than drawing it accurately. All right, let's move on to question 2. It says express this as, so we want to express this as this form, all right? 2x squared minus 8x plus 5. And how do we express in this form? Well, you complete the square. So if you want to complete the square, you factor out the 2, right? This is something we have discussed. So x squared minus 4x plus 5 over 2. So if I factor out the 2, I get this equation. And then now I can complete the square inside the bracket. So x minus 2 squared. This gives me x squared minus 4x plus 4. But I don't need plus 4. I need plus 5 over 2. So 5 over 2 is 2.5. And I think, so this expression, right, gives me x squared minus 4x plus 4. But I don't want plus 4. I need to minus something so that I get to 5 over 2. So 4 is just 8 over 2. So I have this expression here. And I need to minus 3 over 2 so that I get 5 over 2. So let me just subtract 3 over 2. All right. And now that I have this, I can multiply through by 2 to get this equation. All right. So I know what A, B, and C is. It's just this expression. And write down the equation of the line of symmetry for the graph of this. So the axis of symmetry or the line of symmetry, XC is, again, like we talked, minus B over 2A. And that is just minus of minus 8 over 2, because B is negative 8, right? 2 times A is 2. So that is just 8 over 4 is equal to 2. So that is the equation of the line of symmetry. And another way to figure out is, remember, you can interpret this as a translation, right? So your graph is concave up because A is positive. So 2 is just A and A is positive, right? Your graph is concave up and you have moved, x minus 2 tells me that you have moved 2 units to the right. So 2 units to the right is, if your vertex is normally at 0, 0, then after moving 2 units to the right and 3 units down, your vertex has just shifted to 2, negative 3. H, k, right? So H is 2, k is negative 3, so 2, negative 3. And your x, the line of symmetry must pass through this x coordinate. So it's a vertical line, so it's just going to be x is equal to 2. So yeah, that is your answer for B. All right, let's look at question 3. Question 3 is very, very similar. So we are asked to express 7 plus 5x minus x squared, that is y, in the form that one. So let me write it as y is equal to, again, we're trying to complete the square, right? So now we just factor out a negative 1. Inside we have x squared minus 5x minus 7. And now x minus, I can write it as 5 over 2 squared. So I get x squared minus 5x, but I also get something extra. I get 25 over 4 here. And I don't want 25 over 4. I need to subtract something, so I get 7. So I get to not only 7, I need to get to negative 7, right? So I have 25 over 4, but my goal is negative 7. So I need to subtract something from 25 over 4 to get to 7. So x, if you solve for x, you're just going to get 25 over 4 plus 7, right? And 7 is just 28 over 4. So if you simplify, you get 25 plus 28 over 4. That is 53 over 4. So you need to subtract 53 by 4 to get to negative 7. All right. And now you can just distribute the negative sign again. So when you distribute the negative sign, you get 53 over 4 minus x minus 5 over 2 squared. And yeah, that should be the expression that we wanted. So we have this expression already. All right. Find the coordinates of the turning point. So the coordinates of the turning point, well, let's write it in a way that we're used to. So x minus 5 over 2 squared plus 53 by 4. So this just tells us of this stretch or the compression. It's just a flip about the x-axis as we discussed. So minus sign, so we just take this as our h. 5 comma 2, and this is our k, 53 over 4. That is the coordinate of our turning point. So yeah, that is the coordinate. You can also write it as 2, 1 over 2. So 2.5, and this, I believe you can write it as, so 13, 1 over 4, I think. Yeah, 2, 1 over 2, 13, 1 over 4. So this is the same expression. So this is going to be your maximum point. And how do I know that it's a maximum point? Well, if you look at the coefficient of x squared, it's negative. And negative means it's concave down. And concave down means it has a maximum point. And the vertex just gives you the maximum point. All right. So we found the coordinates. So this is 0, and it's a maximum point. All right. So we are done with part 3. Moving on to part 4. Part 4 is essentially the same question. So I'll actually leave it for you to try. So let's do part 5. So find the minimum value of this one. So, and the corresponding value of x. Well, we know that whether it's a maximum or minimum, a turning point occurs at minus b over 2a, comma, c minus b squared over 4a, right? So you can remember the formula. You can complete the square as well, whichever you're more comfortable with. But we have derived why a maximum or a minimum, which is the turning point, occurs at these points. So minus b over 2a. Minus b is negative 7. And 2a is just 2 times 1 is 2. And c is 8 minus b squared is 49 over 4. And we can just simplify this. So we have 3.5, 7 by 2, comma, 8 minus 49 by 4. So 8 is 32 by 4. So 32 minus 49 by 4, that gives me minus 17 by 4. And another way to write it as a mixed fraction would be to write this expression as three half, right? So 7.2 is 3.5, which is 3 halves. And I believe that is 4 and 1 by 4. Yeah. So negative 17 by 4 can be written as negative 4 and 1 by 4. So this is concave up, right? Because 1 is positive. So we have a minimum point. And the minimum value of the function is the y coordinate. The y is your output. So this is your minimum value. All other y values are going to be higher than this. And at what x value does it occur? It occurs at this x value. So corresponding value of x is 3.5. When x is 3.5, your minimum, you obtain the minimum value of your function. And the minimum value is negative 4, 1 over 4. And yeah, that is about it. So again, it's the same question. So we have 1 plus x minus 2x squared for question 6, y. Right? So let me just factor out a negative sign. So we have minus 1 minus x plus 2x squared is equal to y. So I can write it as minus 2x squared minus x minus 1 is equal to y. And let me factor out the 2 as well. So factor out the 2, I get x squared minus half x minus 1 over 2. Alright, so now that I've factored negative 2 out, I can now complete the square inside the bracket. X minus 1 over 4 squared. If you try to complete the square, you'll get x minus 1 over 4 squared. And minus 1 over 4 squared gives me an extra term of 1 over 16. But we want to get to 8 over 16, right? So we want to subtract something so that we get negative 1 by 2. So what is the value of x? X is going to be 1 over 16 plus 1 over 2. So 1 over 16 plus 1 over 2, that is, I believe, 9 over 16. So you need to subtract 9 over 16. Alright, so now that we have this, we have negative 2x minus 1 over 4 squared plus 18 by 16. Or another way to write it is actually 9 by 8 plus 9 by 8. That is more proper, in my opinion. Alright. So now we have written it as 9 by 8. So in this form, so we want 9 by 8 first. Minus 2x minus 1 over 4 squared. 2x minus 1 over 4 squared. Yep. That is it. And sketch the graph. So we want, let me just give you a very rough sketch of the graph. Your vertex occurs at 1 over 4. So 1 over 4 comma 9 over 8. That is your vertex, right? So 1 over 4 is somewhere here. 9 over 8 is somewhere here. So that is your vertex. Somewhere here. And let's solve for the intercepts. If x is equal to 0, y is equal to 1. So you intersect here. So your vertex is at 1 over 4 comma 9 comma 8. Your 0 comma 1 is an intersection, so y-intercept occurs at 0 comma 1. And now you will probably have two x-intercepts. Your graph looks something like this. And now your x-intercepts, you can just plug in, right? So if I solve the equation, so if my equation is 1 plus x minus 2x squared, and y is equal to 0. So if I multiply by negative 1, I get 2x squared minus x minus 1 is equal to 0. And if I solve for x, x is equal to minus b, 1 plus or minus the square root of 1 minus 4 times 2 times negative 1, right? So that just gives me 1 plus 8, and that is just 9 over 4. So 1 plus or minus 3 over 4. And x is just equal to 1, or x is equal to negative 1 by 2. Those are my 2 points. So either x is equal to 1 comma 0, or this point is just negative 1 half comma 0. So that is what my graph is gonna look like. Comma 0, 0, comma 1, and pretty much it. We have a maximum point at 1 over 4, 9 over 8. So that is what your graph is gonna look like. All right. So prove that the graph of this does not intersect the x-axis. All right. So we have the equation y is equal to x squared plus 2x plus 5. Now there are two ways that are very obvious to me to approach this question. One way is you can just put y is equal to 0. And when you solve the quadratic equation, you will see that this quadratic equation has no real solution. And how do we see that? Well, if I use the quadratic formula, x is equal to minus 2 minus b plus or minus the square root of 2 squared. 4 minus 4 times a is 4 times c is 5 over 2 times 4 is 8. So I have minus 2 plus or minus the square root of 4 minus 4 times 4 times 5. So I have negative 76 over 2. And you can't take the square root of a negative number. So this is undefined, because the domain, which we will learn in a future chapter, is always greater than or equal to 0. So this is undefined. So therefore, the equation has no real solutions and therefore no real roots. So that is one way to solve the equation. That is one way to think about this. Another way that is probably more elegant is, let's complete the square. So let's factor out the 4. We have x squared plus 1 over 2x plus 5 over 4, right? When I factor out the 4. And now let me complete this square. So x plus 1 over 4 squared. So that gives me 1 over 16. So I have x squared plus 1 over 2x. I have 1 over 16. And I need to get to 20 over 16. So I need to add 19 over 16, right? 19 over 16, I believe. This should be correct. So if you look at this, let me just check. So this gives me x squared plus 1 over 2x plus 1 over 16. And 1 over 16 plus 19 over 16, that adds up to 20 over 16. And 20 over 16 is just 5 over 4, I think. Yeah, that is exactly what we want. All right, so this is correct. So we see that the vertex is at 1 over 4. Sorry, it's at negative 1 over 4, comma 19 by 16. Sorry, my bad. So we can distribute this 4. So we have 4x plus 1 over 4 squared plus 19 by 4, right? This times this, it's going to cancel out in the denominator. Because 16 is 4 times 4, so 1 4 cancels out. So your vertex is at negative 1 over 4. So you need to multiply through before you can decide where the vertex is. So your vertex, remember, this is minus of minus 1 over 4. So if you want to decide the coordinate of the vertex, you need a negative sign here. So you have minus 1 over 4, comma 19 over 4. So this is your vertex. And another thing you can deduce is that this is concave up, right? So A is positive, so it's concave up. So this is your minimum point. As your minimum point, if your minimum point is bigger than 0, so 19 over 4, that is 4.75, right? That is almost 5. So negative 1 over 4, 19 over 4 is maybe somewhere here. And then you have a concave up graph. So obviously, this is going to have no x-intercepts. No x-intercepts. So, of course, if it doesn't have x-intercepts, it does not intersect, right? It's always bigger than 0. This is bigger than or equal to 0. If your minimum point, the y-coordinate of the minimum point is bigger than 0, then of course every other y-coordinate of your function is going to be bigger than 0. Why? Because it's concave up, and that if your minimum point is bigger than 0, every other point is going to be bigger than 0. All right. So that is another way to think about question 7. Now we have question 8, and we want to find the equations of the parabolas. All right. Let's start with A. So A, we can use, one way to do it is the equation for A is, we can use this form, ax minus h squared plus k. We know the coordinates of the vertex. The vertex is at 4, comma 2. So we can just substitute that information. X minus 4 squared plus 2, right? So we see that the vertex is at 4, comma 2. We want to set this equal to y. Now take any other point. So any other point that we are sure of. And 2, comma 6. We are sure of this point, right? When x is 2, y is 6. So we just want to substitute that. So a, 2 minus 4, negative 2 squared plus 2. If I subtract 2 on both sides, I get 4 is equal to 4a. So therefore, a is equal to 1. Now that I've solved for a, so the graph a, I can write the equation as 1 x minus 4 squared plus 2, which is just x minus 4 squared plus 2. So that is the equation for my graph of a. X minus 4 squared plus 2. So I am done with a. Let's look at b. Or c, I think, is easier. So for c, it's the same idea. We use a, x minus h squared plus k. Let's say this is equal to y. The vertex is at 2, comma 8. So h is just 2, k is just 8. And we expect a to be negative, right? Because it's concave down. So we just substitute 1 point we're sure of. If x is 6, y is 0. So a, x is 6. So 6 minus 2, that gives me 4 squared plus 8 is equal to 0, right? So a, 4 squared is 16. So 16a is equal to negative 8. A is negative 1 by 2. So therefore, for c, the equation is negative 1 by 2, x minus 2 squared plus 8. So yeah, 8 minus 1 by 2, x minus 2 squared. So that is essentially what the equation is for c. And now for b. We are going to use the same trick. So y is equal to ax minus h squared plus k. And we know h is just negative 2. So minus of minus 2, that gives me plus 2. And k is just negative 6. Negative 6. All right. And do we know any other point? Well, if x is 0, y is 10. So we can substitute 0, comma 10. So a, if I substitute x0, I have 2 squared minus 6. So 16 is 4a. A is just 4. So therefore, for curve B, the equation is 4x plus 2 squared minus 6. And yeah, that is it. So we are done with question 8. Alright, question 9. So question 9, we are given that this diagram has 8 parabolas. We are given the equation of 2, and then basically we want to match the curve and the equation of the parabola. So we can use these two to figure out all 8. So let's use equation 1. Equation 1 is y is equal to x squared minus 6x plus 13. And I want to complete the square. If I complete the square, I get x minus 3 squared plus 4. And this tells me that the vertex is at the point 3, comma 4. And this graph, because the coefficient of x squared is positive, this is concave up. So the only two graphs, C and A, have a vertex. So I'm going to say this is 3, comma 4. And only A is concave up. So A is going to have the equation x squared minus 6x plus 13. All right. Let's look at our second equation, which is this. Y is equal to minus x squared minus 6x minus 5. We can factor out in negative 1. So if I do so, I get x squared plus 6x plus 5. And if I complete the square here, I get x plus 3 squared minus 4, I believe. And if I simplify, I get x plus 3 squared plus 4. And I get the vertex at negative 3, comma 4. So if I go to negative 3, comma 4, which is, I believe, this point, then I have two graphs, right? One is concave up, one is concave down. E is concave up, G is concave down. All right. So now, what I'm going to do is this is less than 1. This is negative. So my graph has to be concave down. So it's going to be G instead of E. So my G has the equation minus x squared minus 6x minus 5. So I know two curves and I have identified G. I know what is A. I can figure out everything else. How do I do that? Well, if you think about it, if I reflect G, if I take the graph of G and I reflect it over the x-axis, this part, okay, let me use a good color. So I take the graph G, if I reflect this part over the x-axis, I get this part. And if I reflect this part, if I reflect this part of G over the x-axis, I get this part. So can we agree that F is just G reflected over the x-axis? So what I observe is F is just G reflected over x-axis. And basically, once you know that, if you want to reflect a graph over the x-axis, you just take negative of the whole equation, right? And why is that so? If I have this equation, if I want to flip it over, I take, this is x squared, I take negative of x squared, right? So I just want to make all the y values negative. And that's gonna help me reflect over the x-axis. So if I have y values, if they're positive, I need to make them negative of their same values. If they're negative, I need to make them positive, right? If I want to reflect over the x-axis. So I take the equation of G and I negate. If I multiply by a -1 throughout the equation, then I should get the graph of F. So the equation of F is just going to be minus the equation of G, which is x squared plus 6x plus 5. So I know what F is. F is just x squared plus 6x plus 5. And let me check. Yep. F is x squared plus 6x plus 5. All right. And I can do the same with D, right? D is just A reflected over the x-axis. So D is just A reflected over the x-axis. So I just put a minus sign over here. So equation of A, if I just negate it, I get D. So I get minus x squared plus 6x minus 13. All right, so I have gotten 4 equations. So I know A, D, G, and F. Now I need to figure out 4 more. So let's look at E, right? So if I know E, I know H. E is just A shifted. I need to shift graph A by how many units? I need to shift 6 units to the left. If you think about it, if I shift A 6 units left, I get E. That gives me E. All right, so I know the equation of A. A is just x squared minus 6x plus 13, right? And we discussed, let's just say this is f of x. If I want to shift this 6 units to the left, then I need to look at fx plus 6. Remember, this is something that we have discussed. If I do x plus 6, then I'm shifting 6 units to the left. And that is going to give me the graph of E. So I just substitute x plus 6 wherever x is. And this gives me x squared plus 12x plus 36 minus 6x minus 36 plus 13. So if I simplify, I get x squared plus 6x minus 13. So I know the equation of E. E is x squared plus 6x, sorry, not minus 13, it's plus 13. Because it's positive here, right? Plus 13. So I know the equation of E. And if I know E, I know H. H is just the minus of E, because H is just E flipped over the x-axis, right? So H is just minus the equation of E, x squared plus 6x plus 13. So it's just minus x squared minus 6x minus 13. That is H. So I know E, I know H. I figured out E, I figured out H. And now I need to figure out B and I need to figure out C. All right, if I know b, then c is just b flipped over the x-axis, right? If I know b, c is just b flipped over the x-axis. Now let me actually give you another insight on symmetry. And that is, if you look at the graph f, the graph f is the orange curve here. So let me just trace through the graph. This is graph f. Now, if you flip graph f over the y-axis, now I'm not flipping over the x-axis, I'm flipping over the y-axis, then I get graph b. And how do I flip over the y-axis? To flip over y-axis, or to reflect over y-axis, you take f of negative x. F of taking negative x gives you basically the graph flipped over the y-axis. So whatever your curve is, right? So f, I know the equation of f. That is x squared plus 6x plus 5. So b is just going to be negative x. So whatever x is, I substitute negative x squared plus 6 times negative x plus 5. So b is just x squared minus 6x plus 5. So that is the equation of b. X squared plus 6x. So x squared minus 6x plus 5. And now that I know b, c is just b reflected over the x-axis. So c is just minus of b. So c is just minus x squared plus 6x minus 5. All right. So now we have figured out, yeah, all the equations. So you just used two parabolas, you used symmetry, you used transformations to figure out where all the other parabolas, the equations of everything else is. All right, so we are done with A. B we will not do because it says we just need to create our own parabola pattern. Then usually you pick one parabola, you translate it, you transform it, you stretch it, you reflect it, you get patterns. All right, so we are done with question 9. So we've discussed two important things. If reflection over the y-axis, you take minus f of x. Reflection over the x-axis, you take f of minus x. So this reflects, f of minus x reflects over y-axis. Minus f of x, this reflects the curve over x-axis. Why does it reflect over x-axis? Well, because it changes the sign of the output y values, right? And f of minus x, it changes the sign of your input values. So whatever you have on your negative x side, that is going to flip over to your positive x side and vice versa. All right. So question 10. A parabola passes through these 3 points. Find the equation of the parabola. So, well, I am given the two roots, right? So let me show you another way to write the equation of a parabola. Let me say my parabola is y is equal to a, x plus alpha, x minus alpha, x minus beta. This is one more way to write the equations. We looked at the vertex form, we looked at the standard form. This is the factorized form. So now, where x is equal to alpha is one root, x is equal to beta is another root. So what are the roots of this equation? We know the roots are negative 2 and positive 4. So x minus 4. So if x is positive 4, then we get 0. And x plus 2. And that is equal to y. So basically, alpha, you just want to substitute from here. 4, and if you substitute minus 2, minus 1 minus 2, that gives you plus 2, right? So basically, the idea is that if I substitute 4 here, I should get 0, which I do. X is equal to 4 gives me 0. X is equal to negative 2. I put it here, I get 0. And then I have a outside. Now I need to figure out what this a is. How do I do that? I use the third point. So negative 24, if I substitute x is equal to 0, I get minus 4 times 2. So negative 24 is equal to negative 8a. A is equal to 3. So therefore, the equation of the parabola is just 3, x minus 4, x plus 2. And you can actually just keep it as it is, but I believe the textbook might want you to expand on this. So if you expand, you get 3x squared minus 2x minus 8, I believe, and that gives you 3x squared minus 6x minus 24. That is the equation of your parabola. So we are done with question 10. Question 11. So it's the same style of question, but this time we don't have the roots, right? Here we had the x-intercept, so that was easier to solve. But now we don't have the roots, so we can't use the factorized form. So let's use the standard form. So y is equal to ax squared plus bx plus c. Substitute the first values. -2, -3. So y is -3, x is -2 squared plus b times -2 plus c. -3 is 4a minus 2b plus c. That is my first equation. Let me substitute my second point. So if I substitute my second point here, I get 9 is equal to 4a plus 2b plus c. All right, so that is my equation 2. And let me substitute my third point. If I substitute my third point, I get 5 is equal to 36a. So I'm just substituting these points into this equation, right? 36a plus 6b plus c. All right. So if you look at equation 1 and 2, so this is equation 3, right? If I write them like this, so 9 is equal to 4a plus 2b plus c. And if I subtract these two equations, 4a minus 4a, this cancels out. C minus c is also going to cancel out. So -3 minus 9 is minus 12, minus 2b, minus 2b. So I'm just subtracting. That is minus 4b. So I get 4b is equal to 12 by 4 is equal to 3. So I know one value. I know that b is just equal to 3. All right. So now that I know that b is equal to 3, I can substitute it into my equation. So minus 3 is 4a minus 2 times 3 is 6 plus c. So if I take 6 to the other side, 4a plus c is equal to positive 3. And I can also substitute b here. So 3 times 2 is 6. I get the same equation. 4a plus c is equal to 3. So let me substitute b here. So 5 is equal to 36a plus b is 3. So 6 3 is 18 plus c. So 5 minus 18, I believe, is -13, right? So 36a plus c is equal to -13. 5 minus 18 is -13 yet. And I subtract these two equations, I get minus 32a is equal to minus 16. And these cancel out. So I get a is equal to 1 over 2. And I can use this to solve for c. 4a plus c is equal to 3. So if I substitute 1 over 2, 2 plus c is equal to 3. C is equal to 1. So finally, I can write my quadratic equation as y is equal to a is half x squared plus 3x plus 1. So that is your equation. So you just plug the values in, you get a system of equations, and sorry, this should be positive 16. My bad. Because 3 minus of minus 13, that is plus 16. So this is still minus 32, so a is minus 1 over 2. So this should be minus 1 over 2 x squared plus 3x. And if I substitute this value here, so I get minus 2 plus c is equal to 3. C should be equal to 5. Sorry, I made a mistake. So c should be 5. All right, so I have minus 1 over 2 x squared plus 3x plus 5. That should be your answer. Yeah. So now we have reached at the final question. So prove that any quadratic that has its vertex at this. So basically, y is equal to ax minus p squared plus q, right? We just use the vertex form. And yeah, for a does not equal to 0, and we just want to expand this. So x squared minus 2px plus p squared plus q is equal to ax squared minus 2apx plus ap squared plus q. And that is it. I think that is exactly what they want us to show. So ax squared minus 2apx plus ap squared plus q. Yep, pretty much. So you just want to use this form, the vertex form. You just want to plug it in and you get this expression. And that is it. That is everything for this topic. All right.